Alright, today we're going to talk about metamorphic rocks. And metamorphic rocks form from heat and pressure. So if you start with heat and pressure on an existing rock, you can get a non-foliated or a foliated metamorphic rock. Non-foliated is usually recrystallized, so it has kind of a large crystal shape. So now if we look, we've got marble, and marble has nice chunky crystals. It looks very pretty. Quartzite has been rearranged, and it's got some pretty chunky crystals. But you notice there aren't any layers to either of those. Our foliated side kind of gives us a layered appearance. So let's start with slate. It definitely looks like it has sheets, and if you look very, very closely, and it's kind of hard to see in this camera, but you can actually see there are layers of different minerals that have been rearranged. So that's our foliated. It has folds and layers. Now, if you take slate and bury it even further, you get phyllite, and phyllite is very, very layered and very, very wavy, and you can kind of see it's getting more and more shiny. So we go from a duller shine color to now we're getting something a little more shiny. Bury it even more, you get schist. Notice more layers, more sparkly as we're going deeper in the earth while we're forming. And the final step of a metamorphic would be gneiss. And if you notice now there's striping in the colors. We have black and pink stripes. That's because our minerals rearrange into striped colors because of the extreme amounts of heat and pressure. So you would find slate closer to the surface, and as you go deeper and deeper into the earth where there's more heat and pressure, you would get further and further down in our steps of metamorphic. And that's for the foliated side of metamorphic. So these are your foliated. Now, all metamorphic rocks have parent rocks. And what that means is they were something else before they turned metamorphic. So we're going to look at some examples. Now, marble forms from limestone. So if you have sedimentary limestone and subjected to heat and pressure, you can make marble. Shale forms into slate. So if you take the bottom of a lake bed, and we have our shale that became the bottom of a lake bed, and now that shale is subjected to heat and pressure, it can become slate. And you notice that the color difference, they're similar, but it gets a little bit more darkened, and it's also a little bit shinier as slate from that metamorphic heat and pressure. Sandstone, our sedimentary rock sandstone, becomes quartzite, and you can definitely tell that these two guys were related, right? So you take the sandstone and you reorganize its crystals, and its recrystallized structure, it's a little bit chunkier crystals. So it goes from sand size to quartzite. So sandstone, quartzite. And then coal, we have bituminous coal, which is our sedimentary coal. So here's sedimentary coal. Well, if you subject that to more heat and more pressure, you get anthracite coal. And they're very similar, except anthracite is much, much more shiny. It also is much cleaner. So if we were going to burn this for energy, bituminous coal puts off a lot more pollution than anthracite coal. But the negative drawback to using anthracite would be that you have to dig so deep in the ground to find this metamorphic version of the coal. So cleaner, but harder to get to. So that's our metamorphic rocks. And again, the metamorphic rocks, we had foliated and non-foliated in all of our different examples.